Hi, so in this video we are going to discuss the formula to find the sum of triangular numbers. So as you can see, I have already noted down the formula and the series of triangular numbers. The formula to find the sum of n terms of triangular numbers is equal to n into n plus 1 multiplied by n plus 2 divided by 6. And this formula we are going to prove by using induction. We'll take some known values and show that this formula holds good for known values, and then we will induce that this will hold good for a general value also, right? So if I take n is equal to 1, that means if we find the sum of first term, it will be equal to, what is the first term? First term is 1, so sum will be equal to 1. And if I put n is equal to 1 in this formula, the sum we will get will be n is 1 multiplied by n plus 1, that is 2, multiplied by n plus 2, that is 3, divided by 6. 2 ones are 2, 2 threes are 6, 3 ones are 3, 3 ones are 3. So here also we get the sum equal to 1, right? So this formula holds good when n is equal to 1. And now we will take n is equal to 2. If we take n is equal to 2, that means we have to add first two terms. The sum of first two terms is equal to 1 plus 3 is equal to 4, right? So 4 should be the sum using this formula. So if we use this formula, the sum will be n, which is 2, multiplied by n plus 1, 2 plus 1, 3, multiplied by n plus 2. So 2 plus 2 is 4 divided by 6. 2 ones are 2, 2 threes are 6, 3 ones are 3, 3 ones are 3. So here also we get sum as equal to 4, right? So this holds good for two terms also. And let me check for three terms. So if I take n is equal to 3, so we have to add 1 plus 3 plus 6. And 6 plus 3 is 9 plus 1 is 10, right? And if I put n is equal to 3 in this formula, we will get 3 multiplied by 4 multiplied by 5 divided by 6. 3 ones are 3, 3 twos are 6, 2 ones are 2, 2 twos are 4, and 5 twos are 10, right? So again we are getting the same result as we got by adding three terms manually, right? And let's check whether we get the same result for 5 terms. I am directly jumping to 5 terms, and to add 5 terms I have to add it till here. So when I put n is equal to 5, that means I am actually adding 1 plus 3 plus 6 plus 10 plus 15. 1 plus 3 plus 6 is 10, 10 plus 10, 20 plus 15, 35, right? And if I substitute n is equal to 5 in this formula, I'll get 5 multiplied by 6 multiplied by 7 divided by 6, right? And if I solve it further, this 6 will cancel this 6, and yes, 5 7s are 35. So this formula holds good for first few terms, right? And now let's assume that this formula is true for first n terms also. And if it's true for first n terms, it should be true for n plus 1 terms also. So if we assume that it holds good for n terms, then sum of n terms will be this formula itself, n into n plus 1 multiplied by n plus 2 divided by 6, right? And what happens if I add n plus first term to this sum? So n plus first term, yes, the formula to find the nth triangular number is actually n into n plus 1 by 2. This is the sum of first n natural numbers, right? So the n plus first term will be n plus 1 multiplied by n plus 2 divided by 2. This will be the n plus first term. In place of n, I am just putting n plus 1. So I'll get n plus first term, which will be this. So the sum of n plus 1 terms will be actually equal to sum of n terms plus n plus first term, right? So sum of n terms over here is n into n plus 1 multiplied by n plus 2 divided by 6 plus n plus first term. So n plus first term is n plus 1 multiplied by n plus 2 divided by 2, right? So from here, if I solve it further, I'll get n plus 1 and n plus 2 I can take common, right? And by 2 also I can take common, and inside the bracket will be n by 3 plus 1, right? Yes. So if I solve this bracket, it will be outside we will have n plus 1 multiplied by n plus 2 divided by 2, and inside the bracket will be, if I take LCM will be 3, right? And this will be n plus 3. So yes, again we have got the result in the same form. So the sum of n plus 1 terms is actually coming out to be n plus 1 multiplied by n plus 2 multiplied by n plus 3 divided by 6. 2 3s are 6, right? And this is in the form of our original formula, which is over here. Sum of n triangular numbers was n into n plus 1 into n plus 2 by 6. And if I replace this n by n plus 1 to find the sum of n plus 1 triangular numbers, we will get n plus 1 multiplied by n plus 2 multiplied by n plus 3 divided by 6. And that is what we are getting over here, right? So the formula to find the sum of n triangular numbers is n into n plus 1 into n plus 2 by 6. So this was all about triangular numbers. Bye bye.